The aviation industry is responsible for about 2 to 3% of global CO2 emissions, but its impact is outsized. High-altitude emissions are more damaging, and as air travel grows, the sector's contribution could soar to as much as 25% of global emissions by 2050. It's a problem so urgent that it's reshaping how airlines, regulators, and passengers think about flying. But solving it isn't as simple as swapping out fossil fuels or planting a few trees. Aviation emissions are a unique challenge. Planes run on jet fuel, a highly energy-dense fossil fuel that allows them to cover vast distances with efficiency unmatched by batteries or hydrogen. Every ton of jet fuel burned produces roughly 3.2 tons of CO2, not to mention the non-CO2 emissions like nitrogen oxides and contrails, which further contribute to global warming. Unlike power plants or cars, which can transition to renewable electricity or EVs, aviation has no easy substitute. A commercial plane can't just plug into a solar panel or carry a battery heavy enough to replace jet fuel. Not yet, anyway. At the same time, demand for air travel continues to grow. Pre-pandemic, passenger numbers were doubling every 15 to 20 years, driven by globalization and the rise of middle-class travelers in regions like Asia and Africa. Even with temporary dips like the pandemic, the International Air Transport Association forecasts strong growth, with billions more passengers expected by 2040. The contradiction is stark. Aviation is both a symbol of modern progress and a continuing climate risk. So, what are the solutions? The aviation industry is exploring several pathways to reduce emissions, but each comes with its own hurdles. One of the most talked about solutions is sustainable aviation fuel, or SAF. Made from renewable sources like used cooking oil, agricultural residues, or even carbon captured from the air, SAF can reduce life cycle CO2 emissions by up to 80%. Crucially, it's a drop-in solution, meaning it can be blended with conventional jet fuel and used in existing aircraft without modifications. Airlines like United and KLM have already begun using SAF on some routes, and airports like San Francisco and Amsterdam have started blending SAF into their fuel supplies. But there's a catch. SAF is expensive, multiples of the cost of regular jet fuel, and production is limited. So in 2022, SAF accounted for less than 0.1% of global aviation fuel use. Scaling it up to meaningful levels will require massive investment, government incentives, and the development of new supply chains, none of which happen overnight. Another potential game changer is electric and hydrogen-powered planes, but these technologies are still in their infancy. Electric planes are ideal for short-haul routes, with prototypes showing promise for regional flights under 500 kilometers. Hydrogen-powered planes like Airbus's Zero concept aim for zero-emission flight by 2035, but they require entirely new aircraft designs and infrastructure, including hydrogen refueling stations at airports. Both options face significant engineering and economic hurdles, and neither is likely to replace jet fuel for long-haul flights anytime soon. Offsetting emissions is another widely used strategy, but it's increasingly criticized. Airlines offer passengers the option to purchase carbon offsets, funding projects like reforestation or renewable energy. While offsets can play a role in balancing out emissions, they are not a permanent solution. Critics argue that offsets can be poorly managed, with some projects failing to deliver the promised reductions, and they do nothing to address aviation's core dependency on fossil fuels. Regulators and international organizations are also stepping in. The Carbon Offsetting and Reduction Scheme for International Aviation, or CORSIA, adopted by the International Civil Aviation Organization, aims to cap aviation emissions at 2019 levels by requiring airlines to offset any growth in emissions. While it's a step forward, critics argue that CORSIA's reliance on offsets and lack of strict enforcement make it insufficient to achieve meaningful reductions. So, what's likely to happen? The future of airline emissions will likely involve a mix of approaches. SAF will play a growing role as production scales up and costs come down, supported by government subsidies and mandates. Electric and hydrogen planes will gradually enter service, starting with niche markets and expanding as the technology matures. Airlines will continue to optimize flight operations, using AI to find more fuel-efficient routes and newer, more efficient planes like the Airbus A350 or Boeing 787 to reduce fuel consumption. But the reality is that aviation will remain a carbon-intensive industry for the foreseeable future. Achieving net zero emissions by 2050, the goal set by many airlines and regulators, will require not just technological breakthroughs, but also systemic change, more investment, international cooperation, and possibly a shift in how we think about flying. For example, we might see a push toward higher ticket prices or taxes to curb demand, especially for short-haul flights that could be replaced by high-speed trains. For passengers, the future may mean flying less, paying more, or choosing airlines based on their environmental credentials. But the responsibility doesn't fall solely on individuals. The aviation industry, governments, and technology innovators must work together to address a challenge that touches every corner of the globe. Airline emissions are a daunting problem, but they're also an opportunity to rethink how we connect the world without costing the Earth. And while the solutions aren't simple, the urgency of the problem means the next decade will be crucial in defining the future of flight. If we get there, the future will be weird and wonderful. To take a flight of fancy to see what air travel could be like in the year 2100, click here. Don't forget to like, share, and subscribe.